Hi, good to see you again. Welcome to Block 2, Solving Problems with Multiplication and Division, Lesson 16, which is the last lesson of Block 2. I'll share my screen. So, in your previous lesson, you learned how to solve problems involving calculating the mean of a set of data. So, recall that if you have a set of data to find the mean, you add all the data points, all the data, and then you divide by how many data points you have. And you extended your learning to find a missing number from a data set if you know the mean. Okay. So if you do not recall what we learned in that lesson, please refer to that lesson and watch the video again so that you learn from that lesson. In today's lesson, you're going to focus on uh, or learn multiplication and division in algebraic expressions. So everything you've been learning in this block of learning about multiplication and division facts, you're going to apply it in knowing how to work with algebraic expressions. I would like to ask you to support our mission to educate a global population of children who may not have access to high quality formal maths education by liking the video, subscribing to the channel, share the video with those you think could benefit from it, and then click on the notification bell so that whenever new videos are released, you will be notified. Thank you. Before we start, I would like you to do the retrieval practice questions in 3 minutes. All right, assuming you've paused the video and you've worked through the revision, the retrieval practice questions, here are the answers. So this one involved the previous lesson we did quite a while ago, I think in term 1, where we explored algebra, how to collect like terms and how to work with algebraic expressions. So here the like terms are the ones with the C. So 3C minus C plus 2C will give us 4C. And then we go to the D, they are like terms. So 5D add 7D will give us 12D. For this one, we can see that the like terms are the ones with the index 2, so the x squared. So we'll deal with that one first. So 5x squared subtract 3x squared is 2x squared. And then negative 2x add 6x. You can see they're like terms because they have just the x. There is no index with the x, just like these ones. So these ones are like terms. So negative 2x add 6x is plus 4x, so positive 4x. Next, you're asked to calculate the area of each shape. So this one is a rectangle, so you just multiply the length and the width, and that will give you 10 centimeters squared. I'm sure you haven't forgotten how to calculate the area of a triangle. So you multiply the base and the perpendicular height, and then you have the result. So that should be 12 meters squared. All right, let's do our new learning for this lesson. If we have 7 times A, by now you should know that that is 7A. So the convention of writing algebraic expressions, we're going to explore it so that you remember what we had learned before, which we will build on in this lesson. So if you really want to revise, these concepts of the real basics of algebra, please go and watch the previous videos that we had done so that you can get yourself conversant again with these concepts. A times A, we know that 4 times 4 is 4 squared. So A times A is simply A squared. All right. 7 times A will be 7A squared. So we write the number and then, okay, we write the algebraic term, the variable next to the coefficient. So the number is the coefficient, the letter is called the variable. All right, let's explore something else. Whitney says that 3 times 9 times r times q is 39rq. What has she done wrong? Think about it. From what you already know about the basic concepts of algebra, what do you think Whitney has done wrong? All right, so here is what has happened. We need to look at the numbers first. So we need to multiply 3 times 9. So 3 and 9. So that will be 27. But would it be right to write 27RQ? Have a think. Of course not. So the concept in algebra is that when we write our algebraic variables, we write them in all alphabetical order. So we know when we do the letters of the alphabet, we know that Q comes before R. So the proper way to write it is 27QR. Okay, let's look at this last example before you do some practice. If I give you this to work out, we can look at it in different ways. We can look at it as a function machine. We can say, well, 8t squared divided by 2t should give us an expression. We don't know what that is. So if we think about it in reverse, for a function machine, if you do the inverse operation, we could say, well, what could we have multiplied by 2t to give us 8t squared? So we're thinking about the solution from first principle, thinking, okay, can I actually figure out what that number could have been? Well, to do that, you could think about a rectangle. You could say, well, let me model this problem as a rectangle, thinking that 8t squared is the area, 2t is part of what we know because we know we have to multiply the length and the width to get the area. Now, if we think about it, we'll say, okay, if I multiply 2t times 4, I will get 8t. But that is not exactly what I want. I want 8t squared. So you say, okay, to get from 8t to 8t squared, I have to multiply 8t by t. So the actual answer is 4t. But there is another way I want you to think about this. So pay attention. Did you remember our lesson where I said, or we learned that division can be written as a fraction and a fraction can be written as division? So actually, this, we can write it like this. Yeah? Because we can write division as a fraction. And then let's actually decompose it to its simple terms, okay? So 8t squared, we know is 8 times t times t. And we know 2t is 2 times t. Now, remember, if I give you something like this, you can say, oh, I know, I can simplify this fraction because it's a fraction. You say, I need to divide 8 by 2. It is the same approach we can use here. So whatever we see in the numerator that is also in the denominator can cancel each other out. So this t can cancel that t out. So t divided by t is 1. So we don't, it's just 1. 2 can divide 8 to give us 4. All right? 2 can divide 8 to give us 4. So you see, we're just left with 4t. I prefer this method if you ask me. Okay, because when we start to deal with very complex algebraic expressions, this is how to really think about it. You may not be able to use this all the time because you'll be dealing with really complicated algebraic expressions, and thinking about it this way is helpful. All right, let's move on. It's now time for you to do some practice questions from what you've learned. So what you've learned that you can use simple algebraic methods or expressions to solve problems, and you can use the method I showed you the last time to simplify complex algebraic expressions where you're asked to divide one algebraic term by another algebraic term. Pause the video and answer question 1 in 3 minutes. Okay, assuming you've paused the video and you've answered question 1, here are the answers. Let's discuss them. This one, you simply have, it's a function machine, so we put in 3, and each time whatever we put in has to be multiplied by t, and that's what the result. This one, we have something, here to get this, you have to do the inverse. Okay, so 3t squared, what would have been put in to get, to multiply by t to get 3t squared has to be 3t. So you can do the inverse operation to get the answer. So this one is the same thing. So if we have 7p as our result, what could have been put in? Okay, so if we're dividing, so we're going that way, we're dividing. So if we're looking for what could have been put in to get this, will be 7p times k t. So it's going to be 7p times kt, the inverse to get this. So it's going to be 7kpt. And that's the same process we've used to get these answers. So mark your work and celebrate your success. Really well done. Pause the video and answer question 2 in 3 minutes. All right. Assuming you've paused the video and you've answered question 2, here are the answers. So mark your work and celebrate your success. All right. Pause the video and answer question 3 in 2 minutes. You could do it in 1 minute. It's not that, I don't think it's that challenging, but take your time, learn at your own pace. All right, assuming you've paused the video and you've answered the questions, here are the answers. So mark your work. You were just asked to find 5 possible lengths and widths that when you multiply them will give you these, okay? And these are the combinations you could have. All right, let's look at a new learning for the second part of our lesson. So sometimes you'll be given expressions and you'll be asked to substitute values into the expression to work out the actual value of the expression. So here we're told that k is 9 and q is 3. So wherever we have k, we're going to substitute that in. But remember, do not make this mistake that students usually make. This is not going to be written as 2 then 9, and then squared. All right. So you have to remember that 2k squared means 2 times k squared. And even this k squared can be written, as 2 times k times k. So when we do our substitution, this is what we'll get. And we'll get 2 times 81. And of course, we know that a fraction can be reworked as division or can be rewritten as division. So this is 162 divided by 3. And that gives us 54. It's now time for you to do the next practice in this lesson, which will take you to the end of the lesson. All right, so pause the video and answer question 4 in 2 minutes. Assuming you've paused the video and you've answered the questions, here are the answers. So here you were asked to sort the expressions into 3 groups. All right. So sorting them into 3 groups mean sorting them into groups that will give you the same result. Okay. So 24g plus 0g is 24g. 12g plus 12g is same 24g. 24g squared divided by g is 24g. 3g times 8 is 24g. So all these will give you 24g. Their results are 24g. So it's about looking at the expressions to see which ones give you the same answer. And then these ones will give you 24g squared. If you look carefully, you would see that they would all give you 24g squared. And then all these will give you So these ones will give you 24g cubed. I think this should be cubed. Okay. Oh, no, no, that's correct. So this should be cubed. So that should be, there's a mistake on this one. Anyway, so all these will give you 24g cubed. Okay. So these ones will be g times 4g is 4g squared times 6g, that's 24g cubed. This will give you g cubed. All right. This should be, these are not like terms, so we shouldn't be adding these. Okay, so there's a mistake here. All right. So you cannot add this g cube and that's g. We shouldn't be able to add them. So that's a mistake there. So you cannot add these and then more subsequently. Yes, you can. You can. Sorry, what am I saying? So you do bid maths. So you do that one first. So let's rub this out. I got myself confused there. Blimey, that shouldn't be happening. A maths teacher. That's sad. Okay, sorry about that. So this one, we do bid maths. So 8g times 2g will be 16g cubed. 16g cubed plus 8g cubed will be 24g cubed. So all these are 24g to the power 3. All right, let's move on. Pause the video and answer question 5 in 2 minutes. And here are the answers. So remember, for a triangle, after you multiply, you have to halve it for you to get the area. So if you're being told that the area is 3p squared, remember that you would have halved it before you get this. So the actual thing you would get when you multiply the base and the height would be to double this. So because you halved it to get this, so it has to be 6p squared. So our combinations should give us 6p squared. That's why we have these combinations. Okay, so you can see that when you multiply them, you get 6p squared. All right, let's move on. Pause the video and answer question 6 in 2 minutes. So assuming you've paused the video and you've answered question 6, here are the answers. So mark your work and celebrate your success. So question 6, you were simply asked to, here you were given 4 cards and you were told to put the cards in ascending order when U is 5 and R is 11. So first, you're going to have to do the substitution. You get the value of the cards, and then when you get the value of the cards, you then, thinking about the numbers, you then determine which of the cards is the smallest, and then you start to arrange the actual cards based on the value you've given. So for example, if you look at this, we're told that U is 5, W is 5, and R is 11. So this will be 3 times 5. Okay, W is 5 divided by 11. So this is 15 over 11. And then this one, W cubed. So that's 125, 5 cubed minus 11 squared. So that's 125 because 5 cubed is 125. Yep, 5 cubed is 125 minus 121. Okay. So that's how you do it, and then you figure out what the values are, and then you can arrange them. Okay. So this one will be 2. Yeah, the R is 11. So it's like saying 22 divided by 5. You can see that should be greater than that. And then, of course, this one. Okay. Next, you're told find the values of W and R that will change the order of the expression. So show how you worked the answer. So to find the value that will change the order of the expression, for example, you just put, values of W and R that you think would make this one maybe increase or decrease, that will change the order of the expression. So any two numbers could do that. You think carefully about. Pause the video and answer question 7 in 2 minutes. All right. Assuming you've paused the video and you've answered the questions, here are the answers. So question 7, you were asked, explain why it is possible to simplify 2b times 5c, but not 2b plus 5c. Well, the explanation is simple. We can multiply these to give us 10bc. We know that by now, but we cannot add these. They are not like terms. Okay? We can only add things that are like terms, or algebraic terms that are like terms. And that brings us to the end of our lesson. So, what have we learned so far? So, you have learned that you can apply the knowledge that you got for multiplication and division to solve simple algebraic expressions which involve multiplication and division. And fundamentally, you learned that when you simplify expressions, you need to make sure that if they're multiplication, you can multiply the terms. If they're addition or subtraction, you make sure they're like terms. And you also learned about using the method I showed you to simplify algebraic expressions, which involve dividing, things that are similar in the numerator and the denominator, so that you're left with very simple algebraic term that becomes your answer. Until next time, really well done for sticking around and learning till the last lesson in block 2. I look forward to seeing you in block 3 learning. Until next time, take really good care of yourself and bye-bye.